Hello and welcome. This is Columbia Basin Research's third video in a multi-part series on using program USER, which stands for User Specified Estimation Routine. USER is a program created by Columbia Basin Research at the University of Washington School of Aquatic and Fishery Sciences with funding provided by Bonneville Power Administration. Today, we'll examine our first of two joint likelihood examples. We'll look at an example when a joint likelihood is needed to estimate all of the model parameters. In this example, lamb survival of bighorn sheep will be estimated based on two surveys of lamb to ewe ratios. Juvenile survival is estimated between the two surveys, assuming the ewe survival probability is 1.0. In the first survey, Y1 equals 150 juveniles observed with an F1 of 273 ewes observed for a total sample size of N1, which equals 150 plus 273 equals 423. A binomial model can describe the first sampling survey results as follows. Here, capital F is the ewe abundance at the time of the first survey and Y is the juvenile or lamb abundance. The likelihood can be simplified by dividing through by F1 ewe abundance, where R is the ratio of juveniles to adults in initial periods. Note that lowercase f is the sample size with uppercase F being the population total. In the second survey, Y2 equals 19 juveniles and F2 equals 158 for a total sample size of N2 equals 177. A second binomial model can describe the second survey results as follows, where S equals juvenile, i.e. lamb, survival. Now we can define the joint model in program USER. Let's fire up USER and work with this likelihood. Type USER into the search bar and select it. Maximize your window. Let's start by looking at the first likelihood. Double-click on parameters and define R as I'm doing here. Again, R is the initial lamb to ewe ratio. Click Next. You can skip convenience functions here. No convenience functions are needed in this case. Click Next. In the likelihood 1 area, enter the likelihood definition for the main likelihood as I'm doing here. Enter F1 for the label and then 1 divided by 1 plus R, the count, then Y1 as the second label, and then the probability R divided by 1 plus R, and then the count. Press the Rename Current Likelihood button and rename the current likelihood Survey 1. Note that you can name these as anything you would like, but let's go with Survey 1 here. Notice that the title on the current content page and the navigation panel are updated to reflect the change. Let's click ahead and show results of the first likelihood as it can be solved. Press Next to go to the Verify Model page. If everything has been done correctly, the user dialog should now appear. If there are any undefined symbols or if the probabilities do not sum to 1.0, you will not be able to estimate the model parameters. If everything checks out, click Next. We have now finished the model definition phase. The parameters and likelihoods are defined, and we move to the estimation phase. We can click through parameter seeds, confidence intervals, and optimizer settings as they should fit this model. More information on these can be found in video 2. We can now estimate the parameters of the first likelihood. Click Next and then Estimate to estimate the model parameters. You will see that the workspace is now locked with your currently estimated parameters. You can see R here if you click on Parameter Estimates. Here it is 0.54951. R is the ratio of ewes to juveniles, and we're going to use this as an input to estimate survival from juvenile to adult in the second survey. Now let's work on the second survey of our joint likelihood. We need to unlock our current workspace so that we can make changes and add our second likelihood. Go to Actions and select Clear Current Estimates and then OK. Then go to Parameters and add a new parameter S, which will be your juvenile survival probability. Click through the convenience functions again. We won't need those this time. And go back to Likelihood Function Survey 1. In order to define the second likelihood, press the New Likelihood button and give the new likelihood the name Survey 2. Hit OK. This will add a new content page under likelihood functions labeled Survey 2. After that, fill in the auxiliary likelihood definition as I'm doing here. Enter the label F2 and then the probability 1 divided by 1 plus S times R and then the count, and then the second label Y2 and the probability S times R divided by 1 plus S times R and the count. Once the auxiliary likelihood is complete, press the Next button And if everything was entered correctly, you should see a message indicating that the model definition is valid, as you can see here. If not, use the navigation panel to return to the pages where the corrections need to be made, and then return to the Verify Model page. Remember, each likelihood must sum to 1. Click Next past parameter seeds and go to the Profile Likelihood Confidence Intervals. In this case, I'm going to set R to 0.01 and S to 0.05 so we can look at our profile likelihood estimates after our parameter seeds are estimated. Next, go to the Estimate Model Parameters page and press the Estimate button. If all was done correctly and the estimation is successful, you may now proceed to the pages under the headings View the Estimates and View Model Diagnostics. To examine the estimates and the suitability of the model for the data, here's the Estimation Summary Report. You can single out parameter estimates by clicking on Parameter Estimates. The result is an initial lambda to U ratio of R equals 0.54951 and a juvenile survival probability of S equals 0.2189. Here you can see our profile likelihoods by clicking on Profile Likelihood Estimates. You notice that the bounds are not symmetric, that there is more standard error on one side than on the other. For information on the other reports in the model diagnostics, it is recommended that you watch video 2 in this series, which explains them in greater detail. This has been lesson 3 on using program user, in which we covered a joint likelihood example. In the next video, we'll cover another joint likelihood example, then abundance estimation and hypothesis testing. We hope that this video helps you get the most out of program user. Again, if you have any questions or comments in regard to program user, please fill out our survey as previously detailed. You can also contact Columbia Basin Research at web@cbr.washington.edu. Best of luck on your estimation routines, and thank you.